And then Jared Huffman. You're back in the heads of this guy. Except for John's, I can tell they're part. And then Ross. Maybe I'm going to move over here. We'll figure this out. All right, ready?
Go.
Perfect. So John, if you want to start us off, you've got the mic. The request is that you give us your name, current employment, and SOLIDWORKS experience. And not SOLIDWORKS experience so much, but more just your general interaction with SOLIDWORKS. Not everybody here is a SOLIDWORKS designer by trade. And so that the audience understands where you're coming from a perspective standpoint.
Hello. As Andrew mentioned, my name is MacArthur from DASI Solutions. I am our services manager across the board now. Been with DASI for about 10 years now. I've been training, support, demos, mentoring services over the years. Picked up PDM probably about 6-7 years ago now and handle most of the migrations implementations these days. Now manager in 4 time zones, I guess, so it's getting pretty blurry these days, but I got a chance to pick up SOLIDWORKS honestly for the first time in a while today, prepping for this demo. Actually I own my own license. I've got a CNC machine I built out in my backyard for designing and building custom electric guitars, so I'm real familiar with G-code. Got a welder in the garage. I don't know that I do a ton of fab these days there, but as you'll probably see in my presentation later, I do a lot with Weldments outside of the welding fab side of things as well. So just kind of speaking to it more from a sport and technical role on that side. So.
Is that mic on?
Doesn't sound like it.
Hello?
Yeah.
All right. Hello. Okay. Yeah, I'm Jared Huffman. I work at Fogg Filler. Been here a little over 2 years, and I've used SOLIDWORKS for about 9 years. My day-to-day, as far as SOLIDWORKS goes, is I do a lot of CAD admin stuff. I do a lot of support stuff, so helping troubleshoot with users, planning policies, that kind of stuff too with Fogg. I also teach Intro to SOLIDWORKS. I'm teaching Intro to SOLIDWORKS at GRCC right now in my class. So with those, you see that experience, you see a lot of ways that things can go wrong, because I'm sure that John gets to see also. Things break for other people the way they never break for you, it seems like. So, it's yeah, so I went to Calvin College. I have 2 bachelor's degrees, engineering and philosophy. And yeah. So yeah, I guess that's enough.
I'm Ross Haan. I'm part of Impact Fab. We're across there's a magical point to right here. All right. So I'm actually not a SOLIDWORKS designer. I use it because I get all the great designs that everybody produces for us to manufacture. So my experience with it isn't on the actual creation side, but it's on the interpretation and completion. So learning, figuring out exactly what people's intent are and trying to make sure that we match that up and then deliver what people are looking to have manufactured.
Perfect. So this is going to be a fun. Does this work? Is this working at all? Okay, you're good. So from my standpoint, I've been a SOLIDWORKS user for a decade and a half or so. We do a lot of admin, a lot of consulting, travel the country, and try to help customers establish best practices. And I also, like Jared, I also teach at a local school and do a lot of admin and different things like that. So hopefully, if I do my job right as a moderator, we'll ask the right questions to the right people and figure out best practices, what we do and don't want to do, and what the impending circumstances are. I think we have a good representation here because John MacArthur can say, and Jared as well, right? From an admin standpoint, this is not ideal, bad things will happen. And then Ross can say, you know, yes, you can draw it that way, but when I get it, you have no idea the misery that we go through to actually produce what it is that you do. I had to talk a little bit, he said all of your great designs, so. Clearly he's not going to say you guys are bad designers, but there's always ways to improve, right? So the first major question is, from a generalistic SOLIDWORKS Weldments question, is there's several primary ways to skin that cat. There's multi-body parts, unique part models of traditionally single bodies put into an assembly, and then a hybrid, or and then if you even want to throw a insert part into another part from a body standpoint. So of those three, which is multi-body part, single body part in an assembly, or some hybrid thereof, we'll start at John again at the end and kind of work this way. What would you classically do, and what are your reasons why, and where would the exceptions lie, and in what instance would you give advice to choose one methodology over another?
Sure. Definitely my go-to is multi-body part on structural members as a whole, just for pure speed of design, and especially editing downstream, right? Trained what's got to be thousands of users now how to get away from the old methodology of designing, the single parts, right? And I painfully went to prepare what was a very simple weldment for this presentation later, and did it the hard way to show that. It definitely hit home that doing the multi-body parts by far faster. Of course, there's some ins and outs to that, but I think the number one thing when you start to get more into a hybrid environment is tracking individual part numbers, right? If you care about the individual part number on a piece of steel, that's going to be pretty hard to track with a multi-body part. It's possible, but it's definitely more difficult. And anything with motion. If you're looking to have a hinge, a swing, a gate on this thing that you want to move later, Weldments is probably not the best way to go with that.
And I would quick interject here. John MacArthur is doing a Weldments presentation. Is doing a Weldments presentation here in the same room in the second session, and he's going to try to bring the practical application to the theoretical discussion we're having here. So from the theoretic standpoint, you're not quite following along, stick around for the next hour. John will blow your socks off.
So I guess if I have anything to add to that, I don't know. That's a pretty good synopsis for me. If it needs to be separated, then you should separate it. If it doesn't need to be separated, then it's better to have it in the same file. So what we're talking about is, do I have one file with a bunch of stuff in it, or do I have an assembly and a bunch of pieces that I throw into that assembly?
So I'm going to challenge your need there. What in your book defines need? Why would you need to have different files? What does that quantifiably look like?
A couple examples. If you have something that is a common part, so it gets used in all kinds of different places, maybe a bunch of different, like I have one plate where we bolt a caster to it. And I'm going to put that in every frame I make, no matter what that frame looks like, I use this same caster plate. Pretty nice to have that as a separate file and throw it in at the assembly level. Then it's, I can control that file separately. Also, if you want to stock that part, track it with a part number is a good dividing line too. If I want to number it, in general, nice to have it separate. If I don't care about its number, it's all going to get made at once, like a whole list of different tubing that's all going to be cut at the saw and piled together, and you don't need them separate. That's when it's nice to have it together.
So moving on to Ross then, if you have these customers giving you their great designs, do you prefer getting one single file that's got all that great design packed into one, or do you like the purchase order that says here's the 40 things that you need to make and the quantities, or what are the ways from an efficiency, effective cost mechanism that you as Ross at Impact Fab desire to get these models? What is best for your company, which of course then turns into a cost benefit analysis for your customers?
Sure, so when we get a model, we're looking at what is it going to take to build this part. And so like these guys have touched on, if it's a lot of individual details that come together in an assembly, then we're going to need to have individual part files for the guys on the floor to manufacture. A lot of times you're starting at different points in the production point. It could be a laser cut part, or it could be a piece of tube. If I just have one big file for all of it, now we're going to have to invest the time into breaking it out into individual files on the back end. And what we always caution on that is that now it's up to our interpretation on what your design may have been. The phone call or email works out great to clear some of that up, but that just adds more time, like Andrew was saying, into the whole process. So when it comes in, with the multi, that just helps us then be able to break it apart more quickly and kick out drawings as needed if there's not individual prints with it at the start.
And correct me if I'm wrong, time still equals money, right?
Most of it.
Okay.
Yeah.
And then I've also mentioned here, Ross is going to have a tour of Impact Fab, which is directly across the street from Fogg here. So where John MacArthur is going to give us the SOLIDWORKS practical application, Ross will give us the actual hands-on, this is how we build it application. So it depends on what you're interested in. You have two great options on the second session to see one or the other. So, do we have any questions from the audience at this point, or are we all thoroughly engaged or thoroughly lost? I'm probably guessing that's one of your two options there.
I see a lot of excited faces.
So, we know the perspectives of which they're coming from, and we answered the basic question. We challenged Jared a little bit on the whys and the wheres. But if we're going to make a weldment, what are we going to typically define as a weldment? Is our definition of a weldment any two pieces of metal, similar metal ideally, we're going to molecularly bond together with melting iron? Is that what we're classifying as a weldment? And is it, or from an audience standpoint, are we thinking of weldment as structural tube, C-channel, angle iron, that kind of thing? Because at Fogg Company, they'll do a lot of weldments out of sheet metal. So we'll get plate sheet metal lasered, bend it up, and weld it together, and that's a weldment, and it truly is. And so the question is, if you're talking weldment as a very generic term, what steps do we take to classify, quantify, and deduct from a weldment as a generic term as a best modeling practice in both SOLIDWORKS and then manufacturing practice from the practical side? It's kind of a long question, but.
My go-to is going to be anything that you're going to order in stock length, right? It does not need to get welded together, melted steel at the end, right? I've had tons of companies with aluminum profiles that bolting together that serves a really good purpose for weldments.
Like 80-20.
80-20 stuff. The major downside to 80-20 that I'd like to throw out there is because it's in a sketch fillet, you cannot turn those sketches off later. So a large assembly with a lot of 80-20 in it has a lot of triangle count that can actually hit performance downstream, and there is no suppressed fillet for that, right? Because it's all part of that weldment. The flip side of that coin though is if you sharpen off all those corners, you don't have an accurate weldment either, right? So depends on how much you're interested in weight and clearances and things on those radii corners. I myself use it all the time for wood structures as well. I'll build a cutlass, go to Home Depot and build whatever I'm looking for down to the 2x4 because it's just cut the length, right? The only thing you really got to watch is, 4 2-foot cutoffs of a 2x4 don't make another 2x4, right? So, and with enough weld, you can probably pull that off with steel, but it's probably not worth your time. But that's not to discount the sheet metal side of it either, right? Companies have made specialties out of welding sheet metal together for years, and in bent form, especially bent simpler forms welded together, are a great example of welding as well.
So when you're classifying a weldment there, you're talking strictly in the SOLIDWORKS feature functionality weldment tool, and that's kind of what the differentiation we're driving at here. You can use 80-20. You can successfully model a lot of 80-20 using the SOLIDWORKS weldment tool, but we're clearly not going to weld, I hope, 80-20 together.
Part of me wishes they would just change the name of it to fabrication or something, honestly.
So I guess on the same question, if I can add something, I guess I don't have anything for that.
Well, what I'm trying to clarify is if somebody in the audience here goes back and says, I'm going to make a weldment because I'm going to grab my big gun and weld something together, so I'm going to use multi-bodied weldments as a SOLIDWORKS functionality. But the multi-bodies that they're going to weld together are all individually laser bent pieces. Right, so that's kind of where we're trying to define the terminology between the SOLIDWORKS weldment feature, weldment as if we do in real life, and then what actual geometry, bodies, and members we're trying to construct. Ross is most definitely going to like an individual part and an individual drawing for every single piece of laser bent sheet metal. But if we have a tube frame that's got half a dozen different profiles, whether it's C-channel or angle iron or tube or whatever, you're perfectly fine with one print to cut a half a dozen profiles of tubing of 100 different lengths and weld it all together to make one. But then sometimes if you have to put a machined or a bent, lasered and bent piece on that, then that's kind of what we're trying to figure out. So to help the audience understand, if we're going to send a Weldments to Ross, and some of it is bent and or lasered and bent sheet metal, some of it is machine parts, and some of it is tube steel, what is it that you as Impact Fab, being Ross, would like to see? What part numbers and what drawings and that kind of thing?
Yeah, so when we're looking at the practical side of, here's a weldment with all the components that go with it, we're really looking for, like Andrew said, if it's saw cut to length, a detailed bottom, that's great. That gives us everything we need to know there. We're not going to need an individual part file, print file for all of those. But now if there's something that's a laser formed piece that gets added to the weldment, to break that out as its own part number, or that's where the advantage comes in, that we can just use what's already been created versus having to go back and recreate it ourselves. Same thing with any sort of machine component. If that would be a piece of bar stock that has holes in it, same thing. If there's a part file for that, that we can now use a drawing of, that then clarifies any questions we have and saves the time on our end, going straight to manufacturer versus spending time on engineering or design.
Any questions at this point from the audience? We're either crashing and burning or doing a really great job at this. So going back to what Jared said earlier about, and John I suppose, unique part numbers, and if Jared has a single tapping pad that he's going to use for every frame that he does, he's going to bolt a caster to that. Can you divulge a little bit more into if it's a stockable item, if it has a unique part number, maybe what your economy of scale is, and how you would manage that? And how you specifically brought up you can manage that one particular file, insinuating that's an advantage somehow. Can you discuss a little bit more?
So it depends on how your company is run, but
We'll assume well.
okay. So all right. So an advantage to having a file that you can manage separately would be you can track individual changes to that file. So if you decide you want to add filleted corners on all your pads from now on to that caster bolt plate, you can do that with one revision instead of trying to remember it every time you release a new frame. Also, this gives you a separate file that you can send separately. So I don't, in SOLIDWORKS, if I make a frame and it's a one-part multi-body file, and I want to send someone my native SOLIDWORKS file to use to manufacture, I'm sending that entire file to anyone that I send it to. Now there are ways in SOLIDWORKS to break that out, but then you're just adding more extra steps in the process there as well. And again, those are now separate files. How well are they controlled by the parent file? It just gets more complicated.
So what about economy of scale? Do we save any money buying from a Ross? This might be a great Ross question, right? Do we save any money buying 1,000 casting tapping pads once and welding them on every frame that we make for the next 6 months versus having you make 4 tapped caster pads every single time we ask you to make one frame?
There's definitely economies of scale when it comes to manufacturing. The time it takes to set up, cut one part, and make that versus I'm running 100 at the same time. So we really base it off of how does it nest out in a sheet of material? If it's a laser process, what makes sense? On the same side, as a well-run company, you don't want to stock inventory for the next 10 years of a caster pad. Because when you do make that rep change, now you've got 10 years of obsolete caster pads that you're throwing away. So we usually say one's probably too few if you're trying to make it a standard, but 1,000, if you're not going to use those in 6 months or less, is probably too many. So
Great. Yeah, so there's certainly a practical limit there somewhere, point of diminishing return. So a question for John then. We've talked about casting pads, or man, I cannot say that word today. Caster tapping pads. And John, you had mentioned earlier about if that you would use your structural members in one single part because it's cut length. But what if we at Fogg Company or Gentex Company or Stone Plastics or whatever consumed the same length, tube, size, steel, everything of a particular structural member in a lot of their weldments? Why would you encourage them to pull a custom part number or a specific part number and say there's a part number for this one length of tube with miters or angles or whatever it might be, because they make, let's say, 1,000 a year? Where does that break down from your structural members versus your tapping caster or tapped caster pad that's machine op, if you will? Or where does that break down?
Sure. You know, I think it's very company specific relative to the number, the quantity, and things that you're doing with regard to that. But you know, at the end of the day, you've just got to be really careful with rev control if you're going to go down the road of an individual part, right? Punching a hole in one of those that's used on 1,000 machines that you didn't want a hole in because of danger there, right? Which you can absolutely do in a weldment without a problem, right? I've seen a lot of companies call that length of tube a particular part number, or maybe it's the size of tube as a part number, then dash the length, you know, to get that unique number on it. And then it's still not an individual part number. They still use it for weldment, but use that part number downstream as more of a body function. And that seems pretty effective as well. You know, the big trick, I think, becomes, you know, rev control on the parts still. Tracking where used gets pretty tricky in weldment, for sure. Been pretty underwhelmed with sub-weldment capabilities with regard to that. You know, so there may lie a benefit in the sub-assembly there as well, because the sub-weldment's not terribly useful there.
I have an example of that too. From my perspective, anyways, as an engineer, I had this come up a couple of years ago here at Fogg where I designed a frame for a purpose, and then we decided, okay, you know, next time we build this frame, we want to change the wall thickness, which for me took only a few minutes and one rev change and I was done. Now imagine if we had individual part numbers for each of those tubes, each segment. Now I would have to go in and replace every single one of them with the different wall thickness version, which would have been, you know, a lot longer of a process.
Most definitely. So whether it's structural member, sheet metal, or some hybrid combination they're in, and I'm just going on the list that everybody should have gotten. So we have our cheater sheets. The way to get people to show up to a panel is to tell them these are the questions you'll ask them. But the really fun part is, right, the audience can ask anything that they want. So feel free to pipe up. Oh yeah, so Ross was strong-armed yesterday into this, so that he's totally winging it. So kudos to Ross on that. So purchased items, whether it's structural members or sheet metal or whatever, what if we have weld nuts from Master Car or D-rings or something that we're just going to buy, source externally, whether it's truly purchased or not, and then put into our weldment? I don't want to draw 1,000 weld nuts, as an extreme example, from McMaster Car into a welded assembly. Yet, now I have two prints, one that says weld all this stuff together, and then the next one says, oh, and weld some more stuff together. How would you address or accomplish that? And we'll start with John and work down, and we'll end with Ross and see what he actually would like to see. So we'll verify the information here.
Sure. My gut reaction says to spin those off as separate parts. You know, it's got a McMaster Car number on it. More than likely, your company has an internal number to that as well that you're going to try to track. And again, trying to find what weldments use that as an inserted part can be pretty tricky. You can use insert part to put those things in place. The downside of that is the location of that is kind of cumbersome, right? It's nowhere near as robust as mating in an assembly. It's at the very least got some standard mates without any kind of real preview, just kind of snaps all over the place. Which is obvious room for improvement there, I think. But alternatively, like Andrew said, you're going to end up with potentially a couple of different prints there, depending on how that breaks down. And then one of the things I'm going to show in my presentation later is what the actual bill of materials versus the welded cut list looks like there. And then there's this idea behind the detailed bill of materials that breaks out those components as well, that combines the two. I don't know if there's a right answer, but those are the kind of ins and outs anyways.
So personally, I'm kind of torn on this issue, so I'm trying to decide which way I like best.
Well, we'll
So-
find the answer here in a little bit.
Yeah, I'll explain. Maybe Ross can tell me which one he likes better. So yeah, I guess I have a feeling where that's going to go. One way is, and this is the way I think of a drawing, is that I have a drawing with a part number on it, and it goes with a certain part file with a part number on it, and that drawing completes that weld nuts and some other items that get welded to it at an assembly level. I now have 2 drawings for that frame. And where do I put the details for, the welder needs to know where to put this cross member. Part of me wants to put that dimension on the cut list drawing because I want the cut list drawing to be complete, so it's done before it graduates to the next level. But I kind of like seeing the location for that cross member, where you're welding all the other stuff together. So I guess that's the turmoil that I have going on right now.
Yeah, from the manufacturing side of that, the biggest hurdle I think we come into with purchase components, especially McMaster or weld nuts, PEM nuts, things of that nature. If it's drawn in there, but then that part file itself is not given as part of the model or part of the package, you guys all know how it will pop up and say, hey, browse your part file or suppress. And if you're not looking at your screen when you open it, and 4 seconds go past and it automatically suppresses, and now it's pulled up the drawing, and now we print it out, we manufacture it, and nobody ever caught that. Oh, hey, it's supposed to have weld nuts on it until we delivered it, and your QC guys look at it and go, yeah, they're a bunch of idiots. You're not putting weld nuts on there. And that's a legit thing, yeah, we should have put weld nuts on there. So that's probably not even answering the question I was asked, other than saying, putting a plug-in for it, if you put in McMaster, weld nut, PEM nut, anything like that, that's really important to send that file along with the weldment. From the manufacturing side of life, we can roll either way. Given the full, complete drawing pack, as it's moving through the shop, a lot of times if it is on the highest level where that's added after everything's there's a smaller weldment, let's say, and there's an upper level that has a few additional pieces to it. We'll catch it on the front end, and then we'll send out both drawings at the same time. So when it's going through the manufacturing process and it gets to the fab guys, they have both drawings in front of them. So they're looking a little further downstream than just the immediate, okay, this is just the weldment. We're giving them, this is the weldment, and oh yeah, there's a higher level that gets these additional components put on there. So that's how we kind of do a little bit of a workaround on that one. Yeah.
So the moral of the story is you want everybody to go home with one bit of information, and that's packing.
Packing is your friend. Yes, that is. Thank you.
Packing is your friend.
Packing is my friend.
Packing is also your friend if you want to correct model. So it's been talked about a little bit, and for those of you that know what we're talking about, you probably caught it like, oh yeah, that makes sense. And those of you that may not have knew what we're talking about, we'll try to clarify here. But John has mentioned a couple times insert parts, and that your where used and stuff gets a little hairy, and I think Jared mentioned that as well, something about, or maybe it was John, something about your mates jumping all over the place. So can we explain from maybe John's application engineer, tech support type standpoint, what is insert parts, what are the implications, and why you do or do not like it, or what some of the challenges are, and then we'll roll to Jared from an engineering standpoint. And I think we'll probably skip Ross at this point because
I don't even know what it is.
Right.
So, well, I suppose you've got 2 things to clarify up front there. There's insert component, right, and there's insert part. Insert component's going to go into an assembly, right? And that leads more to the conversation of we're taking these McMaster car parts, for example, throwing them in at a hybrid model level with the weldment. The insert part function is the idea of taking that same part, and instead of throwing that into an assembly, you're saying insert part that's making an external reference out to another part file on the hard drive. The idea behind it is that they all update downstream, right? But something to understand about external references is they only update when files are opened in RAM, right? unlike a SOLIDWORKS part in an assembly, right? So if you change a part file, the next time the assembly is opened, it's going to show the changes. That's not necessarily true on an insert part to another part file, right? There's some settings inside of SOLIDWORKS that are external references that handle whether or not it opens that part, whether it prompts you about that change downstream. So to one of his points earlier is, I want to rev one file and hit all these machines. Well, that may or may not be the case the next time you open it during an insert part, so you got to be a little careful with that. The insert part, building that external reference, for the most part, I think works pretty well, as long as the next person in line that grabs that weldment understands that implication, right? And that's kind of the same as it goes with all external references, in my opinion, which was the last panel I was on talking about that. So.
So yeah, his insert part, basically, you have a part, and now you want to add another part inside of it and create this one new, basically your part now includes the other geometry. And it builds that geometry by looking at the other part file as an external reference. My standpoint on that is almost never do I trust external references. So kind of an extreme viewpoint, but it will burn you. You just have to decide whether you're okay with that or not. And so that's my perspective on external references, and that's what you're doing when you do an insert part. And it's a lot harder to guarantee, like John was saying, that are they going to get the latest thing when they do open it. And again, when you send that package out, if it's a pack and go, maybe you could tell me if it's going to include that part or not, but
or if it even needs to.
Yeah. You're going to get the last state that file was in. I'll put it that way. It doesn't include the part. Is that correct?
It's going to include the body. I don't believe it includes the part file. I'd have to test. It'll include the body in the last saved state of the weldment. So unless that was opened with all of its references prior to pack and go, you're potentially sending an old version of that out.
So my follow-up question would that be, how would you manage revision or configurations? If I have a weld nut, PEM nut, insert something with 10 sizes of configurations, how do you manage that as insert part?
I think you don't.
So maybe that's your answer.
You're going to get whatever one you put in, right? And then you're stuck with that.
Short of making a whole lot of configurations of a weldment, which I don't recommend.
All right. Well, this has been fun. Let's move on. If you're modeling a hybrid type weldment, where we have some sheet metal, some purchase parts, some machine parts, some structural members, etc., etc. Where, if I already have a hybrid going, where is my determining factor of what I'm going to multi-body and what I'm going to dump into the assembly? I've already got the assembly, that's free overhead, and I've already got the multiple drawings. Where are you going to say, hey, I can stick all this in one multi-body part, or I'm going to break it up? One great example that I've seen in my consulting experience is multiple sub-weldments of a frame that have bolt pads for shipping. Can I put all that in one part file, call it a day, or would you have an individual part for the logic welded assembly and extended from there? We'll start with Ross this time, see what he would like. I have 3 independent frames that I bolt together. Can I send you one part file drawing and say, make this? Or would you rather have 3 part files and drawings with an assembly showing how they're bolted together? And we'll work backwards to the SOLIDWORKS application. It's a good question.
Yeah.
He has to think that long.
We get them both ways, so it's trying to decide what actually works better through the system, or really either works for us, because we're going to interpret that as if it's separate for each weldment then it's pretty clean and simple for us because we know exactly what each one entails, versus one file for all 3. There could be issues there, but
Depending on the size of the file, is that advantageous to be able to break the files out and assign one or multiple fabricators per weldment? I mean, if each weldment is 40 hours to make, is it beneficial to have 3 discrete drawings and say we got 3 guys working on this one, 3 guys working on that one, 3 guys working on that one? Or where does that break down from a manufacturing cost benefits analysis?
Yeah, it's driven by timeline and manpower available. So if it's something that a shorter timeline and just to physically get it done, it was 120 hours, but you want it in a week or something like that, well then we have to have multiple people working on it simultaneously. So that really lends itself to having each individual print part file versus just one.
Okay, and then my last question is, I'm sure this never happens in Impact's tenure, but let's pretend one of your competitors messed something up and they had to send it back, right? How does it work to send back a third of a part and say fix that? I mean, is there any logical, coordinated challenges in that type of a realm where you now have a single part file that's cascaded to multiple structural weldments that you drop in a truck and ship to somebody? Or maybe that, I mean, that never happens in, you know, at Impact, but just from a hypothetical standpoint.
It's just like a design, you forget to do something, turn something on, and just like a manufacturer, you go followable and for us, we just make it work and you get it picked up and we make it happen. Like at that point in time, the damage has been done, so we're not quibbling over, oh, if this was a part file or not this part file. It's like, oh, it's your guys' fault. Like, yeah, no, we don't. That's on us, and so we pick it up, make it happen, and it doesn't really have a big area.
Just sending back a third of a part, you just make it work.
It's odd on the paperwork because you're sending back a third of a part. But, you know, it's fine.
You get a third of the part number, or is it just a part with one dash?
It's just one dash.
Okay.
Yeah, it's like a third. 4.33 if you want to be technical.
Okay. Fraction's more accurate.
Yeah.
So I was just thinking about framework that I used to design when I worked on blueberry harvesters, and the frame was 4 side frames standing up and a top frame on top of all of that. And so this would be about a 10-foot tall by 20 feet long, 10 feet wide piece of framework, all welded together in the end. And a couple things that stood out to me about that example for this discussion are the way the welders would put together the frame is they would weld each side frame independently first, you know, laying down on a table, then assemble all those pieces, line it all up and weld the top frame onto all of those other side frames, and add cross members and everything in between last. So that's the way they wanted the drawing structured. Now SOLIDWORKS could handle all of that, but there's a couple limitations that I ran into. First of all, SOLIDWORKS is not great at having more than one sheet on a drawing. So anytime you had sheet 2, sheet 3, it's really slow in my experience. And I haven't seen that change in 9 years. So that's a limitation. And so I don't like multi-sheet drawings because by the time I have 3 sheets on there, it takes forever to work on. The other limitation I ran into is, so it would be really cool so I could control this whole frame through one part file. I had all of that in one giant 3D sketch, which was super cool. If I wanted to change something, I could change the length of it, and all 4 side frames get longer at the same time. The cross members on the top frame move with it. But that file, if you're able to keep track of all those relations and understand how that 3D sketch works, which is really hard, SOLIDWORKS is not. So every time you rebuild those relations, something goes in a different order or something in a different place is going to break. I got really good at 3D sketching working on that, but ultimately decided that I was going to break those up into separate part files so they were manageable pieces for my own design performance reasons.
So I'll quickly interject here a question before we get to John, but in an instance like that, we're farther down in our agenda here, but in an instance like that, would you do a master 3D skeleton sketch in an assembly and use external references to drive your 2D sub-weldment sketches so that you have the best of both worlds? Or does that just make John's skin crawl?
didn't think of that at the time, but yeah, maybe, I don't know. I don't know if there's too much benefit to it. Ultimately, you know, if I want to change the length of those side frames, I'm changing 4 numbers instead of 1. In the grand scheme of things, it wasn't that crazy.
With good design intent, everything should space and update anyway.
Yeah.
John?
So I guess first, speaking to the master sketch idea, it's definitely a daunting tech support ticket to call into somebody that, hey, I've got this monstrous sketch I've worked on for a month of my life that drives 7,000 parts and this piece doesn't work right.
Well, they never showed up with that. They just send you a file.
So, well, even when I get the file, right, I have to deconstruct the, you know, the intent behind that monster to get from point A to point B there, right? The other side I've seen done as well, in line with that idea, is some, you know, just global variables that are driving some of those lengths as well, right? And that's kind of a middle ground, I suppose, right? I don't have this monstrous sketch that has a bunch of relations to it, but you're looking at, you know, length of the sub-weldment as its own global variable downstream. Those get equally hairy when you start talking global variables at an assembly level, though, because of where they have to update downstream as well, and there's a lot of deconstruction that has to happen there to diagnose what's wrong. You know, and I think you're at the nail on the head of the 3D sketch idea, right? Like there's a beauty to the skeleton frame, but at the end of the day, it's a lot of math to chug in one sketch for SOLIDWORKS. It's a lot of math for the end user to keep control of all the time. And, you know, that's assuming you didn't hand it to the next guy to make a change to it, right? Because he's got to figure all that out again now, right? So as a whole, I like to keep it simple methodology when it comes to stuff like that, Ken. Although repetition, you know, begs some automation there, right? So, you know, you've got to kind of draw your line to where I'm not going to draw the same weld foot 1,000 times in the next week, right? But, you know, you didn't want to make sure you're not shooting yourself in the foot in the wrong one there too. So.
Awesome. So do we have any questions from the audience yet? Been awfully quiet. Really? All right, so if you're making a drawing of your weldment, do we do any type of configuration for isolation of one or multiple bodies? Do we do the sub-weldment methodology to try to do the layered step, like the Lego type step assembly instructions? Do we use the relative view command? I'm glad I wrote that down because I totally blanked on that. Relative view command to grab one or multiple bodies. How do we effectively take a weldment that's got anywhere from 2 to 24 or 200 structural members, some of which are common in the geometric size and shape so that they're commonized in the cut list? But how do we effectively extract the necessary information as designers, put them on a 2D detailed print so that we can give it to Ross, and at the end of the day we can be reasonably assured we're going to get what we want?
So relative view is definitely a cool tool. The downside to it that I found is there's a pretty serious overhead that comes with it, right? You know, you're saying take a view and hide everything but what I want to see in it over and over and over again, right?
Just 3 dozen times.
You know, and then kind of going back to a prior point of, you know, that spills onto page 2 and page 3, right? Part of that performance hit is that you're really asking SOLIDWORKS to load the weldment, you know, 7 times these 2 pages, right?
Well, then you have projected views off the
right?
relative
And you're projecting off of that, you know, so, you know, they show it in the book, it shows really well with a weldment with 6 pieces and they kick off a view of it, but you get in the real world and I think that gets pretty cumbersome. I've also noticed that the bounding box of the view can get really odd. It gets very large in size relative to the weldment size. And then you start trying to smash all that onto one piece of paper, which visually, you know, the math data fits on your 8.5 by 11 or whatever, but the views are now overlapped, right? And that can get really nasty trying to drop a note in and balloon things that are in the wrong view due to this overlap. So relative views definitely got its downsides there. The unfortunate part, I think, is though that it's probably the best scenario in that multi-body weldment, because otherwise you have to kick off those individual bodies as part files and track them down and make drawing out of those separately. And if that's the road you want to go, you can, but you have more file management to handle there now, right? So best of both worlds for me. I try to only break out what I absolutely need to from the manufacturing side, right? I'm assuming you guys are going to cut stock lengths to length. If anything's got a compound angle cut on it or something, I need to get you a view of that downstream, right? And I've always tried to look at what I'm producing as can it be manufactured. And that largely comes from my background and the fact that I have a CNC machine out back that I don't have to build this stuff when I get done with it, right? So,
Yeah, I use relative view. They do have now for view, you can click the select bodies button even if it's not a relative view and choose kind of very similar to relative view. The difference would be with relative view, you reorient that piece, that structural member by choosing faces basically in the model to say what's going to be the front, what's going to be the top, that kind of thing. And I still think it's the best. I kind of agree there are some limitations. Another one I would bring up is that it doesn't reorient very well. So if your piece, like let's say I had something that was drawn on a 45-degree angle to gusset in my frame, and I wanted to show that straight horizontal on my drawing. Well, now I change that to a 30-degree angle. My best way to do that is delete the view and redraw it, because there's no way to re-change. You can rotate view, but now I'm punching a number to say how far I want to rotate that view, and I'm basically chasing, you know, if it's not a nice number like that, like it's 27.1536, now I have to put that as the angle that I rotate my view, so you're fighting that. The other thing I want to point out, kind of relevant to that discussion, is in a cut list, you can add angle to the cut list. Part of the cut list functionality is to show the angle of angled cuts on each end in your cut list, which I think is not a substitute for actually showing the view and dimensioning it. You know, you want the picture, but if somebody that's fabricating, that's cutting this, sees angle 00, angle 045, that 45 tells them, oh hey, I better pay attention to this one and see this is not a straight saw cut, something is different here, and look for the view.
well, you got to question anything beyond 45, like where'd you measure 30 from? So,
Even 45, I would still include the view.
Sure.
But having those numbers there tells you, okay, it's not 0, so something is up here.
And the challenge with two, whether 45 or not, the challenge with two miters is that you have a 25% chance of being right from an orientation standpoint, right? Are you building a box, or is it a Z or a staircase? Or there's a lot of variation there if you're just relying on textual numbers and not an actual graphic view. So going to Ross now, of the multiple great drawings that you get, what do you see and what do you prefer when it comes to sheet number 1? Here's our cut list, or here's the general ISO of our weldment. Sheet number 2, here's all the individual bodies. Sheet number 3, here's all our welding detail. What is your idealistic best drawing, but moderately complex, right? We're not talking 3 things you just weld together. What is it that you like to see? And keep it in mind, you know, time is money. The less time you spend on it, the less expensive your bill is, and the more money everybody makes.
So for our team, we don't like anybody on the shop floor trying to make an engineering decision when it comes to a design. We really try real hard that anything that leaves the front office going out to the team on the floor is thoroughly designed, detailed, so that there's no guesswork of what was the intention of this or how was this interpreted. It's very clear cut. So, you know, for us, if you err on more information than less information, that's great, and we can always distill that down if needs be, but I'm trying to think of a time where I saw, you know, a weldment or a print pack come in and I was like, oh man, they detailed too much on this print. They want to scale that back a little bit, just, giving me a little less information here, it would have been easier. But understanding for you as well that your time is valuable, and to go through and detail on every little mundane thing, and that's a lot of effort as well. So there's that fine line between what's the necessary dimensions, you know, if it's a 2x2 tube, I don't need you on the weldment to tell me, you know, measure 2x2 on the tube, but I do need to know maybe overall lengths, and like Jared was saying, you know, your 45s, you know, which way do you want those, or some of those, the critical information that if you just, I always think if I just handed this to some random guy in the shop, would they be able to look at it and understand what I wanted? And if it's, oh yeah, things are dimensioned, there's a clear call out, a good bomb, then I can hopefully sleep pretty easy at night.
All right, we're running out of time, but I'm running out of questions, so this is working out well. Do we have any questions from the audience to substitute our time running out? Yes, sir.
Question for Jared. You were saying before that you can't orientate the views, right? Can't you just right-click on the line and you can say rotate to be horizontal? Can you not do that with certain views? So I do that all the time if I've got, say, a vacuum cup at 30 degrees and I want to machine a pocket for that into a piece of aluminum. Right, I can stick that view up at an angle and now my view's at a weird 30-degree angle. You can click any straight line on there, say rotate clockwise to horizontal, or rotate counterclockwise to vertical or something like that.
Did the tech support guy know?
I don't know if that works in a relative view. Obviously,
That's what I'm wondering.
Yeah.
Straightforward, easy yes and no's.
Yes.
We'll see, all right. So Ross would like to see the weld beads modeled on the parts. So from a SOLIDWORKS standpoint, do we want to model or not model the weld beads on our weldments? Well, you've got the microphones. Have you ever seen a print with weld beads modeled on it?
I have, and I was actually, we looked at it and said, what's this? And I was like, oh, I think that's the weld bead. We're like, oh, that's sweet. I didn't know you could do that. A good weld call-outs of what you're looking for the weld. I don't think it's necessarily worth the time to, I guess I don't even know what it takes to put in the weld bead in there, but for us interpreting the data, if you just have clean weld call-outs that show what you want, or, you know, stitch weld or fully welded, or, you know, that's all we need for interpreting that data. It makes for a pretty model and pretty pictures if you have, you know, weld beads in there and things of that nature, but I don't know what it's going to do for your processing power and space.
Yeah, so real quick, I don't have a lot of experience with that at all. I've never worked somewhere that even suggested we do that. And from the SOLIDWORKS side, it's kind of something I keep an eye on, and through when I'm teaching in class, it does come up. And from what I've seen so far, the tools are changing really fast right now for that, and so as an engineer, I'm kind of like, whoa, just settle down, figure out what you want to do, and then I'll learn it. So you can do what you want with that. Sorry, Ben.
So I've messed around with the weld bead in SOLIDWORKS actually from day one. One of my early on projects was working on some weldment stuff in SOLIDWORKS 01, and at the time the weld command basically could only do vertical weld parts together, so it wasn't terribly useful. You know, that said, it actually made a solid body that calculated mass and weight inside of the model as well. The newer utilities that Jared's alluding to here is the weld bead command in SOLIDWORKS, and it is largely doing a very cosmetic thing, right? So it's not going to add a ton of overhead to the assembly. That started pretty crude, quite frankly. It's come a long way in what it can actually accomplish. I've got some examples in the next session as well of that. You can pull off the stitch welding and things like that in there if you want, but to me, at the end of the day, if your fabricator is not going to consume that as how to weld this together, I don't know that it's worth your time, right? You know, if you guys are building off a print, all the fancy welds in a 3D model in the world aren't going to do much good, right? And they do not translate direct over to the print, right? There are some commands in the print that I can show you as well, you know, but it depends on what you're trying to accomplish. I mean, I've seen plenty of shops that they point an arrow to the corner and say weld here. So if that's good enough for what you're trying to do, then cool. If not, you know, again, the good weld call out is really where it's at. One thing I can say about the weld bead command is that it does do the correct call outs. So as you put on a stitch or a stagger weld and things on that, as you're making some radio button choices, it generates that weld call out for you, which is a far cry from the print when you have just an arrow and then you have to determine how that all should look, right? And if you've ever tried to do the weld call out on a piece of paper in SOLIDWORKS, you pretty much need a degree to understand what's going on with the weld call out of SOLIDWORKS. That's not a SOLIDWORKS thing, right? That's coming from the ANSI standard of welding in America at this point, I think. So there's some costing things to that as well that are kind of interesting. I'll show you some of the backbone information that's in there. But you know, in theory, if you got a fully weld model that was accurate, you know, you could open up that file in SOLIDWORKS, apply your numbers to how much cost is associated with the weld, and it should spit you out a quote pretty quick, which is a cool idea. But costing and engineering are two very interesting animals together in the room, right? So you know, that's kind of the ins and outs of it at this point, I think.
So follow up on that point, Sean Bentley out back is currently doing an FEA presentation. Does FEA have any impact on your weld beads if you're trying to do an FEA weldment?
Not to my understanding. They're purely cosmetic. The weldment command by itself, if you're using a structural member, automatically translates that member into what's called a beam element in simulation. That beam element is assuming that you have a strong weld in that corner, and we're not analyzing whether the weld is going to fail. We're analyzing, will the beam buckle, will the structure fail within that. That's the default. You don't have to leave it as such. You can choose to shell mesh or solid mesh welded items as well, but you're likely going to run into contact problems with respect to that. Penetration and no penetration things on there are going to be problematic. And as a whole, you know, most weldments, and correct me if I'm wrong on the fab side, don't necessarily always touch one another, right? You want that for strength all the time, but weld gaps are really important with respect to manufacturing tolerances as well, and that becomes pretty tricky from an FEA standpoint. So as a whole, FEA is ignoring welds and assuming that that metal is stronger than what was there to start with.
Perfect. So one last question, I think. Well, do we have any questions from the audience? Right? Well, two-part question. First question is, do we prefer master 3D sketches, 2D sketches built off planes, or 2D sketches built off structural member weldments as they are created? So you get your daisy chain effect.
For the most part, I prefer the latter, mostly because I can get things to update downstream. I get to build in design intent relative to that edge. If the edge moves, if that weldment member moves. There's certainly some credence to planes as well in there with respect to symmetry, especially. You know, I think the symmetry side of things is really important in weldment. Choosing the right zero is also a really big one. One gripe I've always had about the SOLIDWORKS weldment training manual is they start a table from the foot up, which has always been kind of strange to me. To me, the top of the table would be your zero as your work surface, and I'm going to say how tall this thing is, but depends on I suppose, you know, what you're looking at as the overall coordinate system there. 3D sketch has its merit. Pretty much the only time I break that out is when I've got compound angles. I'm not going to try to lay out a compound angle plane just to have a 2D sketch here, right? I'm going to do what I can with 2D sketches, connect the dots with a 3D sketch, right? And the best thing I can tell you about 3D sketching is to get all of your hard lines first, throw in sketch fillets and things like that later. And that's not necessarily even just for weldments, but across the board. Sketch fillet works really well on compound angles after the sharp corners are put in.
All right, well, one more answer here from Jared, and we'll call it around.
Okay, well, quickly, I'd probably, yeah, I would almost always go to a 3D sketch. And I don't know if that's because that's how it was taught, but it certainly makes sense through my line of thinking of I'm planning the way I want this framework to look. I may change the sizing, stuff like that, but I'm going to model my profiles based on design intent. So if I want the framework to expand inward, and as I go around, you know, I sketched and dimensioned the overall outside dimension. That's just the way I see a weldment, especially a framework, when I'm designing it. So it makes sense to draw it that way in SOLIDWORKS for me. When you start daisy chaining and breaking up the design, it gets harder to see from the top level how those changes are going to affect other pieces of your same model. So that's why I like seeing it all at once in a 3D sketch. And I'll break it out for performance reasons, or if it's just really cluttered, if there's a lot going on with it. But the flexibility there to change it. Also, one thing, you can't turn a 2D sketch into a 3D sketch. So if you start with a square and you decide you really wanted a line going up from that and to make a cube out of it, if you started with a 2D sketch, now you're committed to that path. If you started with a 3D sketch, you don't have to redraw, you can just continue on your way with it. But I do agree with some of the advantages and disadvantages there.
I think they've now made it so you can mirror a 3D sketch, I want to say in 17.
I thought that was 18.
Is it 18? We'll say it.
Something
Test it
close.
again. They're working on that. That's one of the other gnarly limitations, right? If you start this crazy compound angle over here, you just want to mirror it over there.
Near the bottom.
So,
I would put the mirror, at the bottom of my tree, if possible, or near the bottom. I want my sketch to be just only what I'm actually designing and not. So, sometimes I'm only going to sketch a quarter of the frame and then use a couple of mirrors to flip it around.
Any other questions? All right, we thank our panel participants for joining us. We'll keep up.